Hi, good day, everyone, and welcome to the Power of IBM Maximo. In today's session, we're going to be looking at how we can transform your asset management, leveraging some new innovative technology. You've all heard of Coco the dog and Spot from Boston Dynamics. So we'll have a look at that today and how it ties in both to Maximo EAM as well as Maximo Application Suite. So join with me today. We have Scotty McLean from Cohesive Advisory Services, Roger Haber from Sales Manager at Boston Dynamics, and myself, Damien de Gouveia, the Asset Performance Management Lead here at Cohesive. So extending the welcome to the rest of the team, we have Spot. And Spot, as you may know, is one of Boston Dynamics' robot dogs that will, in our use cases, assist with autonomous inspection, as well as a few other use cases that we'll go through in the slides today. Now, what you may not know is of Scott's little cousin, Coco. Coco is Cohesive's effective version of Spot with similar functionality and ability. And of course, this is Fluffy, a real dog known for its hair shedding device efficiency. So if you'd like to know more about that, please do not join this webinar. Just kidding there. All right, so just to set the scene before we dive into it, we need to understand how exactly all these different aspects fit in together. So when we're looking at Spot as well as Coco, we're talking about autonomous inspection. Now, within the broader Maximo application suite, autonomous inspection can either fit into visual inspect, monitor, or running through the condition monitoring capabilities of your traditional Maximo EAM, or manage as it's branded Maximo application suite. The key objective here, at least, is to really articulate that by extending the Spot robot dog and Coco, we can really leverage their capability as an autonomous vehicle to really try and enhance where Maximo previously couldn't or didn't have the capability to go. And of course, when we're thinking about all these different technologies, the one thing to keep in your mind at least is both Spot and Coco are these vehicles that will go out and actually capture the data, a vehicle of data ingestion, something that could essentially really move, see, and sense, with the overarching purpose, at least, to inform us all about all this new information. So we'll have in the presentations today a lot more of an in-depth discussion around how exactly does it move, how exactly does it see and extend the sensing capability beyond what Monitor could potentially do in Maximo Application Suite, and enhancing those capabilities with Visual Inspect by using some of the imagery taken from either your traditional cameras, infrared cameras, or a number of other image sensing or visual methods of capturing data, and using computer vision to determine anomalies, identify and classify particular imagery. Now, if you'd excuse the little pun, with moving, sensing, seeing, and informing us all, we really hope that you do not miss out on what is to come. So starting off, we're going to roll over to Boston Dynamics, and I think yes, there we go. Mr. Herbert, can you please take over?
I can. Thanks, Damien. So just look at the next slide here. My plans are to give you basically background on, let's see here, on the company and a very short introduction to Spot, the robot that Damien mentioned, and then some of the capabilities it can offer you. And so very quickly, many people may be aware of our company, Boston Dynamics, but you may not be aware that the company is over 30 years old. We've been performing and designing and building robots for those 30 years, but really only the last 3 years have we been a commercial company selling robots anywhere in the world, Spot being that first one. And so you can see here where we focus Spot and where it's going to fit in this environment for the crowd here on the phone, on the meeting, is really hits three main areas. It's going to be this repetitive data collection tool, so Spot can autonomously walk around your facility and perform these rounds and readings applications or services that your team is already performing. So instead of taking a clipboard or a tablet around the facility and checking on your assets, allow Spot to carry those sensors for you, perform that inspection autonomously. And we'll look at an example of that. And then, of course, you have this idea of safety. So if you're performing those rounds and readings in hazardous areas, where maybe it requires two people to perform these inspections, one person outside the zone and one person inside the zone, of course, letting robots do that is going to be advantageous. And then the last thing we'll talk about is this idea of remote operation. So being able to remotely operate a robot, either from many states or countries away, or just in the same facility. Stay in your air-conditioned office, log into a robot that may be in a building next door, perform an inspection, get eyes and ears on what may be happening, and make better decisions about your plant processes. So a couple main things about Spot. So we'll see it here in just a minute in a short demonstration, but it can get around like people can, up and down stairs, over curbs, walking in gravel, those types of things. It can be fully autonomous. So we'll look at that, teach it a mission, and have Spot replay that mission on a schedule. Every day at 6 o'clock, every Saturday at 9 o'clock, perform an inspection mission. If obstacles become present in that mission that were not there when you first recorded this, Spot can then navigate around those. It has built-in obstacle avoidance. It will not run into things, whether those things were there previously or not. It will avoid obstacles. If it does fall down, which it could, it can get itself back up. It has about a 90-minute runtime on a charge. It has a self-charging docking station it can return to charge as needed. It does have an open API, so working with Cohesive to use that API to move data into your maintenance management system or to perform other types of inspections and tasks, adding sensors, etc., can be performed. And it is water and dust resistant, so rain and dust rated. So let's look at a short video here. This is Spot on its docking station, standing up. This is less than 1 minute video. You see Spot walking around the facility. This is a pre-recorded path that someone has recorded once, and Spot can then play that back over and over again. And it's going to stop where you told it to stop at certain assets and perform certain sensor measurements at those assets. In this case, it's doing a thermal inspection of a motor. You can see that there. Now we're looking at a gauge and performing a gauge reading. You can trend on that value. Here we're showing a picture of a fluke sensor that's tuned to detect compressed air leaks in manufacturing. And here is a third-party sensor for performing a 3D scan, so to get a digital twin of your entire facility. And so that's really these common inspection types, right? Thermal, gauge reading, acoustic imaging, and then the digital twin creation. There are many, many other types of sensors that could be added and are being added to Spot. Things like radiation sensing, gas sensing, even visual vibration sensors can be added as payloads onto Spot, depending on the inspections that you require. So the way this works is in this teach and repeat. So you build an autonomous mission once by using the handheld tablet controller, which you see a view of on the screen here. You drive Spot with the built-in joysticks to an asset. You point the sensors, in this case, a thermal imaging. You point the sensors, set up your inspection tasks, in this case, this region of interest. I want you to tell me if something is too hot in this area, and record that maximum value so I can trend it. And so Cohesive can pull that data out of Spot, move it into your maintenance management system, and now you've got this trend data of the temperature of this asset over time, as well as alarming that's built in. And the way Spot does this when you're in the record mode is it operates in this idea of creating a map of the world around it. So get to the next one here. There we go. So this is kind of what Spot sees. So when you're training Spot in this teach and repeat function, you drive Spot around the facility, again, stopping at the assets. It's building a map that looks something like this. And so it's building this world that Spot is going to operate in. It will never wander around your facility and go look at places it's never been. It only knows the map that you've taught it. Hey, Spot, remember this map, play yourself back in this map. And so it builds a map something like this. And the reason I show this is you can see there's, in this area of this map, at least 2 different loops, maybe others as well. And so the benefit of that is, again, Spot is fully autonomous. And so if Spot's walking in this larger loop, you see the main rectangle there. And one of the pathways is blocked. Someone put a pallet down, piece of equipment is in the way, and Spot cannot proceed through one of those hallways, it looks like here. Then Spot knows, oh, I can't get there this way. The path is blocked. I have obstacle avoidance. And so it will then turn around and walk entirely around this loop to get to the other side of that blockage and continue its mission. And it does that because it knows the map. It won't wander anywhere else, but it knows there's a loop in this map, so it knows an alternate way to get around obstacles that may be present. And that's fully built in and autonomous with Spot. So let me tell you about 3 different use cases very briefly to get you thinking about where other customers are using Spot. So one is in outdoors and combustion turbines, so power generation facility, using Spot to perform autonomous inspections. And we can see back there behind this picture is a set of stairs, and these stairs go up about 10 flights or so. And Spot proceeds up to every level, performs thermal inspections of the steam generator, looking for leaks using its thermal camera. And also at the top, there are gauges Spot needs to read, performs that mission. And this company can also use the remote access, which we'll demonstrate to you as well. This next one here is another power utility. So this is at a substation. So again, they have both indoor and outdoor at this facility. So outdoor, you can see there in the picture, Spot performed autonomous inspections, thermal inspections of transformers, but they're also able to use Spot in an unsafe environment because of the high electromagnetic field. This particular substation has a high voltage DC conversion, and so it's an entire building that humans cannot be in during operation of the system because of the EMI field strength. So send Spot in. When you get an alarm, find out what's happening. Can you continue operating the facility? This last one here is from the Rail Authority in Paris. And so you can see these pictures, some pretty tight and scary looking places. So think about your confined space inspections you need to perform. In this case, using Spot's thermal camera and visual camera to perform inspections where they have low oxygen environments and areas that operators don't want to go, which you can see why. Using Spot's lights and its sensors to perform these inspections and keep the operators safe outside of those zones. So another good application there for Spot. So I think now we'll move to a demonstration. What I'm going to do is I don't know, maybe 1,500 kilometers away or so of this robot. So I live in the middle of the United States in the state of Tennessee. And what I'm going to do is I'm going to log into a robot that is in Boston. Let me share this screen here. And so what I've done now is I've switched. I'm in a web browser. I've now logged into a system in Boston. Again, I'm not sure, 1,500 kilometers away, 2,000 kilometers away from me, something like that. I see I have one robot connected to the system. I'm going to choose to drive that robot. You'll see it'll log into that robot. We're now looking through the robot cameras. This is a live video feed. So I have several options here. But I'm going to do first is just say power on and undock over here on the left side. So I'll choose that. It'll take a few seconds. Spot's motors will power on, and you'll see Spot stand up in front of its docking station. It is currently sitting on a docking station. I can see there was a battery charge icon there. So it stands up, stops in front of the docking station, ready for commands. So in this case, I can use my mouse, this cursor that you see. Anywhere I click, I can just click that button, let go, and Spot will navigate itself. In that case, it walked over that rock pile. I can also use the keys on the keyboard. So W, A, S, and D. So if I choose D, I can turn Spot to the right. I can walk forward with W and you turn to the left with A. Again, we talked about stairs. So if you just get Spot near stairs and you hold down the W key to go straight, Spot continues to walk up the stairs like this. And now that we're up here, let's look at using some of Spot's sensors. And so I'm going to switch from driving mode up here in the top right to inspecting. And now in inspection mode, we're looking through Spot's camera on its back, its payload sensors. This bottom view is a 360 view all the way around the robot. And so if I wanted to point the camera, maybe directly behind us here, I can click that in the 360, it'll point the camera there. So now we're looking sort of to the rear of Spot. Move that out of the way. And this particular inspection payload has the ability to zoom. And so there's a zoom slider, or we can draw zoom boxes like this. That slider looks like I hit the wrong thing there. Get that slider back, zoom back out. But we're able to use this optical zoom on Spot, which maybe we can look this over here and see what the snacks are today, to perform this zoom inspection. And really use the optical zoom that's built in. So we can nudge the camera a little bit if we want to move that slightly left or right as we zoom further to perform this this inspection. Again, you can do this all from the distance. In my case, I'm performing this from multiple states away. Looks like we got some pretty decent snacks today in the snack bar. You can also, of course, zoom back out. And then look at using the thermal mode of this camera. Again, this payload has a thermal camera, a separate lens. So I could look over here on the left-hand side and Spot cam. I can choose turn thermal mode on, which will switch to the thermal mode and give me temperature measurements, min, max, and average temperature throughout that region of interest as well. I'm going to switch that back. I'm going to point the camera forward. Actually, let's see, I'm going to switch back from inspecting to driving. Look out Spot's rear cameras. I'm going to hold down the S key, and we'll just drive Spot backwards. We'll drive Spot back to the docking station. So I'll switch to the forward camera and we'll turn so we can walk forwards. And we'll drive to the docking station. I'm going to play one short mission where Spot's autonomously driving itself. So there's the docking station. You can see home button pops up to allow us to just click and dock. What I'm going to do is I'm going to choose play mission. I've pre-recorded. Remember, teach and repeat. We've pre-recorded a mission. I'm going to say play this one that recorded in March. It just has 3 inspection points. So I chose to play that mission. Again, you can schedule this mission to say, hey, every day at 6 o'clock in the morning, perform this mission autonomously. And so it should be loading that mission now. And again, no one's driving this robot, it's driving itself. And so it's lining itself up with its start of the mission. And now it's off performing these inspections. It may take an hour walking around your facility, performing these autonomous inspections using the sensors that you've configured. What you don't see here, we're looking through robot cameras. You don't see the sensor view when it's in this autonomous mode. So what it's doing on the left, you can sort of see there's motors. We have some demonstration motors. They're not on right now. They can generate heat. It's performing a thermal inspection of the motor to its left. But then it's going to walk forward and perform a thermal inspection of that motor. You can see just a little bit there on the top left. So it performs that and goes to the second one here, performs the same type of inspection, thermal of the motor. And then we'll take one more gauge inspection after this. So really the power here is the ability to both have remote access to perform that driving mode like we just did, where we can take over, drive the robot in an area from afar, again, like I did, from multiple states away. Then you also have this ability for Spot to perform autonomous missions, all by itself. And so it's performing here. It's going to go up those same stairs, and then I'll show you the data it acquires. It's acquiring data. In this case, it's reading that gauge that's right in front of it. You can see there. So again, the cameras you see here are not the inspection cameras. These are just built-in robot cameras for obstacle avoidance. But what you don't see is the inspection that it's making of that gauge. You might see the body adjust just a little bit here. That right there is it's framing up the image in exactly the same way, to take that data in exactly the same way from exactly the same angle, so you can get the same results and trend on those results and kind of trust it. Otherwise, you might have maintenance person A and maintenance person B perform inspections from different locations, different angles. And so the data is not as correlated as it could be if a robot's performing that every time. Now you see Spot returning to its docking station, and it'll dock itself and be ready to go for the next scheduled mission that you might have. So once it docks, I'll go let it do that. I'm going to go ahead and choose session history very quickly to show you the data that's coming back from this. So that data is still uploaded from that mission. You see there's lots of missions on this demonstration robot, but this one has been run 64 times. Here's the gauges that you see. That's the last inspection point. Then we had the motor inspection. In most cases here, the motor wasn't turned on. You don't see much heat. Here's one maybe where it was I don't think it was on there either. This one looks like it was on at some point. Yeah, there's a good inspection of the motor being on. And of course, we have the raw data. You can see here where you have the radiometric data. You can see what the temperature was at this location or at this location. It's all available. And then, of course, a trend line that you can perform as well. So this is fundamental kind of basics, what's built in here. And then what Cohesive can do is take this data and really plug it into your maintenance framework, plug it into your CMMS system, generate work orders based on the results from this. So I'll stop there. We look for any questions you have at the end.
All right, thank you very much. I think next up, we're going to hand over to Scotty McLean, who's going to really touch on how exactly Spot and Coco, as alluded to earlier, integrate into the wider Maximo application suite and how that can really be leveraged within your organization. I just like to note, and I forgot to do this earlier, so my apologies, that this session is being recorded. But I think on that note, Scotty, over to you.
Thanks, Damien. Roger. So afternoon, everybody. So I'm just going to actually do some repetitive stuff that Roger's kind of already said to you, with just maybe a little bit more detail, just to give you a better understanding of where we're going with the robot. Next slide. Can you go, Damon? So basically, the common inspections we have within it's all based on payloads. So the robot technically is a delivery device. It's going to take a payload, whether it's the optical zoom camera, the thermal camera, the acoustics, or LiDAR scanner, or we can put a gas detector on it, and or if somebody's doing any of the RDI vibration monitoring, that can carry that camera to multiple locations instead of having one camera in one location that can carry it multiple places. So it's just delivering the device, whatever it's on its back, and it can carry multiple things. It can carry up to about 30 pounds. So you don't have to just have one thing on it. You can have multiple devices on it for it to go out and collect that data for you. So you go on the next slide, please. So basically, what do we have today? So just to give it, so you have people going out and looking at inspections today. 2 human beings. Okay, Damon, next one. And this is some of the data that, Roger mentioned before, that, you do stuff today from a condition monitoring point of view, and people go out and record values from gauges, whatever it is. And this is some of the stuff that you would get back. So here's an inspection that someone goes and does, and then, I get it back on a piece of paper, complete with a coffee stain, and I have to take that data somehow and make it into an actionable item. So the robot it becomes a lot more efficient. So really what you're doing today is those existing inspections you have in the system today, and we'll stick with the thermal inspection. So within Maximo, I'm going to have my Maximo job plans that says, here's my thermal inspection. I need to go to motor number 1, motor number 2, motor number 12, whatever the number is. And I need to do it in this sequence because I've maximized or optimized that route for a human being to go do it. So it's more efficient for him or her to go get that data. So what I have to do with the robot is, here's the inspection points. I have to measure, I have to kind of link that motor to an asset or location in Maximo. And then what am I actually doing to it? So it could do multiple things when it's doing there. It could take a gauge reading. It could take multiple thermal pictures from different angles, whatever you want it to do. And then what we do today, it's actually very easy to train the robot on what to do. And in reality, and why we showed you the first slides with the actual inspections you do today, because if you have someone doing the thermal inspection today, even another human being, if I take that camera from Roger and give it to Damien, I have to show Damien where to go and what to do, which is no different than I do with the robot. And in reality, to train the robot, it takes no more than about 20 minutes for Roger or I or anybody else from Cohesive to show you how to train the robot. But you're doing the exact same thing as you do with a human being. I need you to go with this motor, and I need you to take these actions. The big difference you get by doing this is once it's all recorded, like Roger showed you, once that mission's there, Maximo is going to kick the PM out. The PM through the integration is going to go to Spot sitting on the dock, and it's going to say, Spot, go do PM inspection number 33, which is a mission. The robot's going to go out and collect all that data and bring it back, and it brings all that data back. So now we can have the insights. But the key to it is, as Roger mentioned, I can give a camera to 3 different people. I can't guarantee that those people will take the same angle and the same picture every single time from the same location. With the robot, I guarantee that the robot will take it within centimeters of where it took it before. It will make sure, as Roger showed you, you can zoom in on that little portion of the thermal image, and you can point to multiple points on that image, not just one. So it's going to guarantee that information is going to get back every single time highly accurately, which now lets me getting into the AI world, that my data is actually pre-cleansed because the robot's doing it for me. So like Roger showed you, this is just another way of doing it. So using visual inspection, we're going to read that volt gauge, and we're going to get a value of 220 volts or 240 volts. That number is going to come back into the system, and then we can tell Maximo what to do based on what happens if you find that. So we also suggest that for every action that you create, we would have a job plan in the system. Say, if this was to happen, how would I fix that object of what? So if I have a high temperature or low flow, maybe I change the pump. I should have that pre-planned job ready to go. So when the robot collects the data and the system tells me I need to replace the pump, we're going to go to the job plan library, pick that job plan and create the work order, and then Maximo is going to schedule. And all that information is tied back and forth, so we know exactly which robot collected it on which day and what's the values we actually seen. Okay, Damon? So again, this is just another image of what Roger showed you, some repetitive stuff, looking at the thermal image. And the next slide should be the graph. So again, like we're just repeating what Roger showed you. All we're doing from a cohesive point of view is we're now taking the data that robot collects, and we're now making an actionable item in Maximo to make sure that if it sees this, then you need to do this. So that the big efficiencies of this is safety is number one. Again, any environment. So a lot of in mining organizations that we're working with, as an example, I can't send somebody into where a conveyor is when the conveyor is running at full speed. But I can't really see if the temperature, if the bearing temperatures on the carrier rollers are bad if the conveyor is shut down, unless I do it immediately after shutdown. Whereas the robot can go in and walk it, and there's no danger to the human being. I can collect data from afar. I don't have to send a human being here. Again, repeating the efficiency. The time to do the inspection is reduced. The inspection's always going to get done. I'm in North America, in Canada. One of the problems we have here, actually, in all of North America and probably Europe too, is a lack of resources today. We don't have skilled tradespeople, or are we using skilled tradespeople in the right fashion? This helps us improve that, because that robot's going to do that inspection every day when it's told to do it. It's not going to stop and talk to its friends. It's not going to deviate from its mission. It's going to do it exactly the same time every single time. And that leads us into, from an AI and analytical point of view, why did we do the thermal inspection only once a month? It really comes down to a lot of cases because we only have one resource to do it. If that resource is not there, he or she, it doesn't get done. I can actually increase the frequency on the robot and have the robot do it every 3 days, because it doesn't take any more energy, and the robot's just going to go do it and collect the data for us. So we improve our uptime. And again, the predictability part of it, again, now we can get the data more consistently, which means we can make much better decisions on highly accurate data. Okay. So really, what do we do? So the data collection, images, temperatures, audio, laser scans, we're going to add that to it. We're going to bring it to a data storage place. We can do the machine learning, however we want to do it. And then we output and dispatch the robot and get things fixed long before we actually had a catastrophic failure. So really, on the surface, there's no change to what you do in your day-to-day business. As it says there, Spot and its payloads are technically a mobile IoT device. So instead of physically mounting a sensor on a motor, which today, depending on where it is, can be fairly expensive, or a stationary camera, the robot now becomes a device to take that camera and go to multiple places. So I can do 5 or 6 motors instead of just doing one that's got that visual inspection on it. It's repeatable, highly accurate, and it's really it gives us a better way of collecting the data. So when we look at it, we have to collect data to make decisions today. So whether it's a sensor, whether it's a human being or robot or a drone, and we'll just mention that here is the Coco or Spot. Coco is the Cohesive robot. Spot is Boston Dynamics robot. It's the exact same robot. We just put a vinyl wrap on ours to change the color, but it's the exact same machine. Whoever's doing that information and wherever we get it from, even if it's from an online data source, which we can do with the new functionality in Maximo, is we're trying to bring that data in that's highly repeatable, it's autonomous, and it gathers consistent data. So again, using what I call facial recognition, I can look at that gauge. Once that gauge has been recorded and we have it, every time I go out and that gauge moves, it's going to give me the gauge reading on that. The only thing I have to say there is why I use facial recognition is each model has to be slightly adjusted based on the gauge it's looking at. So you have to say how many faces are there in the world. And then once I've modeled your face, I can pick you out going through the railway station in Belgium if we need to. It's the same with the gauges. The gauges aren't always mounted 90 degrees. They could be mounted 45 degrees. They could be mounted upside down. There could be a glare. There could be dirt. So for each one of these visual inspections, each one of them has to be tweaked a little bit to get the right information based on the gauge it's trying to read. Okay. And so where does all this information lead us to? It leads us to what we call a digital twin. So this is an example of the data going out and being collected, and we have some alarms. So we've gone out and collected some data, whether it's a human being, online data, or the robot. And you can see here that in this digital twin, I'm seeing that pump in the alarm. I can see the alarms on the upper right-hand side. And then down here, I can see hypothetical events are failure modes. So if you're doing anything from a RCM, FMEA, all that information is connected. Here is the actual failures, the events. I can see the Maximo work orders. I can see the P&ID drawings. And because I've selected that pump already, when I opened up the P&ID, it went out and found that exact pump. And now it's looking at the process automation data for that exact pump that I've actually collected. So that's online time series data. I can see the gauges all the way through. Now this one's looking at pipes. Again, the capability of using RBI, risk-based inspection, looking at the degradation of how a pipe moves. I can see that pipe it's got some failure modes on it, and I can track that all the way through. So again, we're taking all the data, Maximo, all the information, and now showing you in a digital twin. This is looking at the same model, but in this case, we're looking at the alarms and the pumps. But one of the things we're going to show you here in a second is that 3D reality mesh, because maybe I don't have a 3D model of this particular section of the plant, but I can use a robot's LiDAR scans. I can use digital pictures, I can use drone flights, and I can build another, what we call a reality mesh. And since Damien's driving, if I move my mouse, you can't see where I'm pointing to, but you can see in the middle of the screen, it's actually changed color a little bit. That's a addition that's been added onto this 3D model that's actually based on a reality mesh. So you can see it change color. So that's the actual valve in the field. And as I scroll out now, all of this is built from a LiDAR scan. So you can see that same valve, but now I can move that whole thing around and I can walk through it. I can do all the stuff from a digital twin point of view. So we've covered quite a lot in a short period of time to give you I think a good overview of the capabilities of the robot and what the information can come back and give us. So in reality, Boston Dynamics has what they call a remote inspection solution. So this would be the package. You would get the Spot dock, which you can see the camera on the front is the digital zoom camera, 360-degree camera, and the FLIR thermal camera on top. It does have the capability of recording sounds, and you do have the capability of two-way talking between someone teleoperating the robot and speaking, and it can actually make some noises if it crosses a walkway or something along that line. Scout is what Roger showed you, where we use to teleoperate and the data comes back. And again, there's other options that you can add on it, but this is basically the kind of out of the box, the starting point for the Boston Dynamics robot, and then working with Cohesive to take those payloads and integrate them into your existing Maximo system, whether it's the 7 series or version or the new Mass 8 stuff. It can connect to either one of those. So I hope that makes sense. And I think we'll take some questions now, if that's okay, if there is any.
Perfect. Thank you very much, Scotty. I'm going to quickly just stop sharing so I can have a squiz at those questions. Let me move over to Zoom again. Right. Here we go. Okay, so the first question that we have, so some of the questions were sent prior to this as well. So we're going to look through some of those questions. And at the same time, I think I'm just having a problem loading the chat. So if there's anyone else on the call who can view the chat, if you can just interrupt me if there are any other questions that have come through thus far. So let's maybe first see if we can run through one or two of the questions that we had prior to the event. And then after that, anyone who'd like to ask any questions in chat, by all means, you can send it through. So the first sort of question here is, and I know you spoke about it earlier, Scotty, but in terms of the Spot sort of integration with Maximo, but from the context of work management, how can it automatically generate work orders or tasks based off of those inspection findings? I know you did mention that, you know, there's job plans that will be activated, but can you maybe go in a little bit of detail about that for me, please?
So basically what it does, it's not actually Spot itself, right? So Spot is a delivery device. What we're doing is connecting to the payloads and bringing that data into a data repository. And from there, and Roger mentioned earlier, there's a whole series of APIs that allows us to do all kinds of things with Spot. So there's basically no restrictions what we can do with it. So we have to work through that workflow to say, okay, we have to link, number one, what we have to do, the recorded mission that we have in Spot, we have to link that to an existing Maximo job plan or PM that gets triggered. So we have to say job plan 33 is mission number 33 on the robot. And that's what we tend to do. We try to make them the same numbers so there's no confusion. So when the mission gets, the work order gets generated in Maximo, we know it has to go collect the data. Just like me giving that check sheet to an individual, I'm giving it to the robot. So we're doing that with APIs. And then when it brings the data back, we're analyzing that data, whether it's in the condition monitoring and saying, when it gets to this value, you need to do this work. So we have to tie all those. When this value equals X, you need to generate job plan number 22, or maybe it's just a work request that can be dependent on the customer.
All right, thank you, Scotty.
That makes sense?
Yes, that makes sense. The next question we have maybe ties into that, in that it asks, excuse me, and then you did address it partly over there, in terms of what other data or can Spot perform anomaly detections. And what I'd like to maybe do is start with this and say, like you said, it's the ability to walking IoT device. So however we can take that information and then use the computer vision either with Maximo Visual Inspect, or perhaps we can also leverage some of Monitor's capabilities, depending, of course, on the frequency of data, that can then be used to trigger some of the anomaly detections. But I know, Scotty, you identified there earlier in plant site some of those sort of integrations and how that all plans together. How exactly can the LiDAR capability help inform that digital twin of Spot itself?
So just clarify the last part of it for me, Damon, sorry.
So sorry about that. So how exactly, let me just get the wording right here. So essentially they're asking, how does Spot's LiDAR capability enhance your digital twin? If I already have a digital twin, I know you touched on it somewhat. If I already have a digital twin, how can leveraging this capability enhance that digital twin over time?
I might ask Roger to help me here a little bit, but basically the robot builds that reality mesh so it knows where to go. So that can be ingested into the digital twin. So that now becomes part of the digital twin. Just like the last diagram showed you where, you've seen the addition to the plant, or last video showed you where you've seen the addition to the plant, and it wasn't coming from a 3D model, a design package, it was coming from the LiDAR scans. So it's going to build that reality mesh based on the information that the robot carries. So the robot can carry not only the LiDAR that it uses to build its own reality mesh, we can put another LiDAR device, a more sophisticated LiDAR device, and I've just lost the manufacturer's name, to give you a more detailed picture of what that plant looks like.
All right.
Yeah, I would just add to that, say, if you, sorry, yeah, Damien, if you have a existing 3D scan of your site, digital twin that you're very happy with, then Scotty showed some videos of measurement values that are being placed onto your existing digital twin. And so if you have a digital twin that's accurate and you know where the assets are, then we're really just mapping new sensor data to those assets that are already in your digital twin. And so that's really just a mapping exercise. Say Spot acquired data from pump 12. We map it to pump 12. It's already on your digital twin, and you can see it that way. So if you have one already, good digital twin that's accurate, you don't need new digital twins, then you can just map the data, the newly acquired data, onto your existing digital twin. So depending on what you have, that can work well.
And then maybe extending that, when we're talking about being able to add on additional hardware, I know you gave examples of some of the things that are both now available and potentially in the pipeline. What else is there for this particular instance of the inspection? So what other capabilities, other than the ones you've mentioned, are either going to be included in Spot or are currently included that we didn't have time to cover in the presentations? So we're talking about physical hardware mounting onto the dog.
Yeah, can I mention a few things? And some of those I talked about, but we have customers, performing gas sensing has been pretty popular depending on the environment. So different types of gases. We have third-party companies that are making these full chemical, biological, radiological sensing packages you can put on Spot. So again, depending on what you may have in your environment. Scotty mentioned a visual vibration system. That's a payload built by a company, RDI Technologies. And so you can perform vibration, not just of rotating assets, but of your piping system, of your infrastructure, and kind of see if that stuff is moving. We mentioned digital twins already. And then radiation is a big one. So some of our nuclear operators and decommissioning sites are using radiation scanners. And so because of Spot's API, you can really take any existing IoT sensor and move it to Spot if it's important to your applications. But those are some of the main ones we see, in addition to what we talked about today with thermal and visual and acoustic detection.
All right, thank you. And
Just to that, add to that, the RDI, the motion amplification that you can look at for vibration, is getting more and more popular because of what it can do. It's not, if anybody's interested, I'd suggest you really look at it, because it can actually see the vibration of the civil construction or the mounting that the pump is actually bolted to. It's not really the pump that's vibrating or the motor. It's actually the foundation that's moving. And we've had a customers that's made some significant gains in fixing things because they can't figure out why this motor is failing all the time, and they've done all the standard stuff to try and fix the vibrations, but it ended up that it was a foundation that was bad. It wasn't actually the motor itself and the pump. And again, I mentioned that earlier, so you can have a stationary camera if it's highly critical that watches that all the time, or the idea behind it is you can mount that same camera on the robot and have the robot walk around and do 10 pumps instead of just one pump.
All right. I think we have one last question and we'll start to wrap up. So the final question, at least, is around maybe scheduling and prioritization of inspections. Can it optimize inspection routes or frequencies based off of asset criticality or historical data? Now, I know we did mention the whole train and learn aspect, but at the same time, noting, as you mentioned earlier, Scotty, about Maximo's scheduling ability. So how does that tie in to scheduling with the intent of a robot as opposed to a human being?
Well, in reality, Spot or Coco or Boston Dynamics, the way it's we're not going to optimize. The robot has no capabilities of optimizing that route. That still comes back to what we're doing in MAS, and maybe looking at RCM or those kinds of tools that we can add in that's going to help us optimize those inspection routes. The only thing I did say is, based on the way the data is getting collected by the robot, in some cases, we're doing a thermal inspection, we're doing it once a month because that's what we have people to do. In reality, using the robot, we might be able to do that in a more frequent frequency because the robot is just waiting for something to do. And it can do it 24 hours a day, 7 days a week. So it can actually do the inspections more often if required than what we're doing with it with a human being. I mean, it doesn't totally answer the question, but there's not a lot of optimization we can do with the robot itself. But with Cohesive and the stuff that we can do from an advisory services point of view, we can certainly optimize the routes better by looking at the way that you're actually doing things, right?
All right, understood.
So in reality, I'll say it this way. Going with the robot, if you're strictly doing a calendar-based PM, you're going to be what we call the 2 zone, too little, too much, too early, too late. What we're trying to do with MAS, and everything we're trying to do with IBM, is move away from traditional calendar-based PMs and go to more condition or predictive-based inspections. So the more data that we collect, which the robot helps us do it, helps us collect it accurately, then we can optimize based on the data coming in. Maybe that's a better way to answer that question than I previously said.
All right, no, thank you very much, Scotty. I think on that note, we can end it off here. As we've said, everyone, we thank you very much for the time that you've spent. If there are any further follow-up questions, please feel free to reach out to us. We'd love to spend some time, and we can also maybe go into a bit more depth, if any depth is required in any of the various areas that we've covered here today. So again, from my side and the rest of Cohesive, we thank you very much. We hope you have a marvelous week ahead.